Hello students, in last class we studied about the equations of motion. In this chapter, motion in straight line. Those are V is equal to U plus AT, S is equal to UT plus half AT square, and the third equation is a V square is equal to U square plus 2AS by using the graphical method. Then, today we study about the distance traveled by the body in nth second. This derivation is related for the numericals, or this formula is related for the numericals. So here, distance traveled by the body in nth second. Nth second. Distance traveled by the body in nth second. Nth second means the last 1 second. The distance traveled by the body in n second is easy, but to find out the distance traveled by the body in last 1 second is difficult. So, to find out the distance traveled by the body in last second is very easy by using this formula. So, we derive this formula. So, consider any object. Consider any object. If this object covers a distance, if a object covers a distance in a n second, suppose consider any object. If the object is in motion and if the object is moving in a straight line, that time the distance covered by the body in n second is. Suppose the distance covered by the body. Suppose the object is initial position is A. After some time, the object is moving in a straight line. Suppose this is a distance traveled by this object in n second. Means the time required to move the body from A position to B position. The time is considered to be nth second. So that is a n second. Take another one body which is moving from A to B. The distance traveled by this is considered to be S1 and the distance covered by the second body is considered to be S2. But here the time difference is there. Here if this is the total time is a time, then here last 1 second means that is a 9 second. Otherwise this time last 1 second means it is considered to be n minus 1 second. N minus 1 second means here the distance traveled by the body in the n second is considered as. And in this equation, we consider the distance traveled by the body in the n minus 1 second. Means what is the distance covered by the body in last second? What is the distance covered by the body in last second? Here we want to find out the distance covered by the body in last second. ಈ ಡೆರಿವೇಶನ್ ನಾವು ಲಾಸ್ಟ್ ಸೆಕೆಂಡ್ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಕವರ್ ಆಗ್ಯದ ಅದು ನಾವು ಡಿರೈವ್ ಮಾಡಲಿದ್ದೀವಿ. So here we don't have the relation for the distance. In the equation of motion by graphical method, we derive that equation S is equal to UT plus half into AT square. So this is a common equation to find out the distance covered by the body. So we use this equation here. Here n is the time. So change that equation. That is a S1. S1 is equal to, when the distance covered by the body in n second, means if we consider this equation is a S here, that is a distance covered by the body in n second, where n is the time. Therefore, S is equal to, we know that S is equal to UT plus half AT square. So substitute the value, where T means n. So S is equal to U means the velocity, initial velocity. The time required is a n plus half into A into t square means that is a n square. Suppose equation number 1. So the distance covered by the body in a n second is, if we consider this value is a s1, the time is a nth second. So distance covered by the body in nth second is equal to u. U means the body is moving with initial velocity u. N means the time and plus half a. A means acceleration. Acceleration is possessed due to the change in velocity into n square. So this is the equation number 1. Then find out the second equation, that is a s2. Distance covered by the body in the last 1 second. Last 1 second means n minus 1. That is the distance covered by the body in last 1 second. Yes, n minus 1 is equal to, where time is n minus 1. So u n minus 1 plus half a n minus 1 square. Suppose this is the equation number 2. Distance covered by the body in the n minus 1 second. Second equation, that is u, time is a n minus 1 plus half a and the time is a n minus 1 square. So this is equation number 2. So simplify this equation, that is the distance traveled by the body in the n minus 1 second. Simplify this equation, that is the s2 is equal to s2 is equal to, simplify this bracket, u into n, un minus u, un minus u plus half a, here n minus 1 whole square. So apply the formula a minus b square. So a square minus 2ab plus b square. So apply the same formula here, n square minus 2n plus 1 square, 1. Again simplify this equation. S2 is equal to un minus u plus, multiply this value to the bracket, half a into this bracket, that is a half a n square. These two to get cancelled, plus minus minus a n plus half a into 1 plus half a. So see this equation, un minus u plus half a n square minus a n plus half a. So this equation is a s2. Then to find out the distance traveled by the body in last 1 second. To find out this equation, s1 minus s2. S1 minus S2 is equal to distance traveled by the body in last second. So S1 minus S2 is equal to S1 minus S2 is known as the distance traveled by the body in last second. So simplify this equation. S1 is equal to un plus half a n square minus, right on the bracket, second equation, S1 minus S2. S1 is equal to un plus half a n square minus S2. S2 is equal to un minus u plus half a n square minus a n plus half a. Simplify this equation. S1 minus S2. S1 minus S2 is equal to distance traveled by the body in a last second, and that is considered to be S. Therefore, S is equal to that is distance traveled by the body in a n second, last 1 second. Sn is equal to, simplify this bracket, un plus half a n square minus plus minus un minus minus plus u minus plus minus half a n square minus minus plus a n minus half a. Cancel the same values. See the equation, un plus half a n square minus un plus u minus half a n square as a last nth second. So this is equal to, if we simplify again this, u, if we take a common, plus a, n minus 1 by 2. If we take a common, the remaining values are n minus half a. So the distance traveled by the body in nth second is u plus a n minus 1 by 2. This equation is known as a distance traveled by the body in last 1 second. So this formula is related for the numericals. So remember this, n means the time is given. So the a means the acceleration, u means the velocity. Okay. So we derive this expression, and that expression is known as a distance traveled by the body in the nth second. Nth second means last 1 second. So if we consider S1, that is the distance traveled by the body in nth second. N second. Second S2. S2 is equal to distance traveled by the body in the last n minus 1. So this is the distance traveled by the body. Here the time is a n. ಇಲ್ಲಿ 10 ಅದ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಅಲ್ಲಿ ಎಷ್ಟಿತ್ತು 9, ಇಲ್ಲಿ 100 ಸೆಕೆಂಡ್ means ಇಲ್ಲಿ 99 ಸೆಕೆಂಡ್. So to find out the distance traveled by the body in the last 1 second, we use this equation, and we know that the related formula for the distance traveled by the body is by graphical method is s is equal to ut plus half a t square. We use that formula. So the first one, S1 is equal to, that is the time is a n. Therefore, S1 is equal to distance traveled by the body n second is equal to un plus half a n square. Equation number 1. Second, distance traveled by the body in the last 1 second. Here the time is a n, means here the time is a n minus 1. So substitute the value, t means n minus 1. So yes, n minus 1 is equal to u n minus 1 plus half a n minus 1 whole square is equal to, simplify this equation first. U n minus 1 bracket un minus plus minus u plus half a. Here we apply the formula a minus b square. Therefore a square minus 2ab plus b square. So in this type n square minus 2n plus 1. Again simplify this bracket, un minus u plus half into a into n square, half a n square minus 2 to get cancelled minus a n plus half a. So here we want to find out the distance traveled in the by the body in last second. Last second is S1 minus S2, and that is known as the distance traveled by the body in the nth second. Therefore, S1 minus S2. Simplify this bracket. First S1 un plus half a n square minus S2. Minus S2 means write as it is the bracket. Then minus into plus. Simplify this bracket. Then we got the value Sn is equal to u, that is the initial velocity, m is the acceleration, n is the time, minus half. So this is the formula. This formula is related to derive the expression for the distance traveled by the body in a nth second. And the idu formula now nth second time find out ಮಾಡಬೇಕು, distance find out ಮಾಡಬೇಕು ಅಂದ್ರೆ ನಾವು ಇದು formula apply ಮಾಡಬಹುದು. Let's see the next part of the chapter. Relative velocity. Relative velocity. Relative velocity is defined as the velocity in between the two objects, or when we compare the velocity in between the two objects is known as a relative velocity. When we compare the velocity between two objects or more than two objects, more than two objects, when we compare the relation of a velocity in between the two or more than two objects is known as a relative velocity. For example, if there are two objects are there, if the first object is a A and the second object is a B. For example, if there are the two objects A and B, A and B, if the object is moved, if the object is moved with the velocity v, means if the first object is moving with the velocity v, suppose the velocity of the A object, if the object is moving in the straight line direction, that is the velocity of this object is a VA. When the object is moved from one place to other place, there is a velocity is there. Means due to the motion, the velocity is a constant, or the rate of change of displacement is known as a velocity. Let's say the first object is moving with some particular velocity. If that velocity is a dA, and again there is another one object B. If B is also moved in the same direction, that is a VB. If B, the another one object which is moving with the same the velocity VB, the velocity of A and velocity of a B both are different. So that time we compare the velocity in between the two objects. Starting initial position is the same, but the distance covered by both the object is a different. That time we say that B is moving faster than A. There are two ways. Ali two ways explain madodu. When B is moving faster than A, otherwise A is moving slow than B. We compare in two ways. That time, when we compare A with B, that time we say that velocity of A is less than velocity of a B. But when we compare velocity of a B with respect to velocity of A, that time we say that B is moving fast than A, or velocity of a B is more than the velocity of A. So in this type we explain this velocity, or when we compare the velocity in between the two objects or more than two objects, that is known as a relative velocity. So here, if we explain first one, when we compare velocity of A with respect to B. When we compare velocity of A with respect to B, that time we write here VAB. Velocity is a vector. So give the argument on the velocity VAB. VAB means we compare the velocity of A with respect to B. We compare velocity of A with respect to B. Both the objects are moving in the straight line direction. That time, to find out the relative velocity in between the two objects, we use the formula VA minus VB. VA minus VB. So this formula is known as the relative velocity in between A and B. This formula is used when we compare the velocity of A with respect to velocity of B. Means when we compare the velocity of A with respect to B, that time we express in this form VA minus VB. Means we say here VA is moving slow than VB. Okay, so this formula is a relative. Otherwise, when we compare second part, remember this formula VAB. When we compare velocity of B with respect to A. When we compare, both the sentences are different. When we compare B with A is slower than B. Otherwise, when we compare B with A, that time we say that B is moving faster than A. Therefore, we write here, when we compare velocity of B with respect to A, we write the formula VBA. This is a relative velocity formula. VBA is equal to VB minus VA. So this is a relative velocity formula when both the objects are moving in the same direction. These formulas are related for the relative velocity or to find out the relation in between the velocity of the two objects. So in this step, this is a related formula VAB when we compare velocity of A with respect to B. And this is a VBA when we compare the velocity of the B with respect to A. Next part, when both the objects are moving in an opposite direction, or when both the objects are approaches to each other, then what is the relative velocity? When we compare velocity of A, these related formulas are there when both the objects are moving in a same direction. But when both the objects are moving in an opposite direction, the relative velocities, if A is moving in this direction and B is moving in the opposite direction, when both the objects are moving in a opposite, these formulas are related when both the objects are moving in a same direction. But when both the objects are moving in a opposite direction, when both objects moving in opposite direction, or both the objects are approaches to each other, that time what is the relative velocity? Suppose VA is moving with the velocity VA, and B object is moving with velocity VB. Then, if we compare velocity of A with B, when we compare velocity of A with respect to B, that time we use the formula the direction is opposite. So when we compare A with B, we use the formula VAB is equal to the related formula is VA minus VB. So here VA minus VB. This is a related formula to find out the relative velocity. But see the direction. VA is moving in the forward direction and VB is moving in the opposite direction. So when we compare the velocity of both the object, VA minus VB, but the direction of a VB is a minus. Direction of a VB is in an opposite direction, means it is considered to be minus. Therefore, this is equal to VA minus plus VB. So this is a relative velocity when both the objects are moving in an opposite direction. When both the objects are moving in the same direction, the relative velocity is equal to VA minus VB. But when both the objects are approaches to each other, or when both the objects are moving in an opposite direction, to find out the relative velocity in between both the objects, we use the formula VAB is equal to VA minus VB. That is formula. But here the direction of B is in opposite direction of A. Therefore VA minus VB minus plus. Therefore VA plus VB. So this is known as the relative velocity of AB. Otherwise, when we compare B with A, that is also the same formula. When we compare B with A, B with respect to A. So that time again same formula PVA, relative velocity in between VBA. This is the type which shows the relative velocity. VBA is equal to VB minus VA. But the direction of A is the opposite of the B, therefore minus minus plus. So in this type, we use this formula to find out the relative velocity in between the two objects or more than the two objects. So here, relative velocity is that in which we compare the velocity in between two objects or more than two objects is known as the relative velocity. When the two objects are moving in the same direction, the relative velocity formula is VAB is equal to VA minus VB. Otherwise, when both the objects are approaches to each other, that time the relative velocity formula is VA is B is equal to VA plus VB or VB plus VA. Then the next part is position time graph for the relative velocity. Position time graph for the relative velocity. Position time graph for relative velocity. Position time graph for the relative velocity. In the last class, we studied about that by taking the position on the y-axis and by taking time on the x-axis, the graph is plotted. That graph is known as a position time graph. And the slope of a position time graph gives the velocity. Or the graph which is related that shows the nature of a velocity. So if we show the graphs, first one, position time graph for the relative velocity. When we show the velocity or we show the relation between the velocity of a object A and B, if we consider the graph, this shows the time and this shows the position. If there are two objects are there, if the first object is a A and the second object is a B, the velocity of a first one is a A and the velocity of a first object is a BA and the velocity of second object is a BB. Means the rate of change of displacement is known as a velocity. So here the A is moving in this direction. The A is moving in this direction. Means this graph is related for the velocity. If we draw the graph, means the position and time. So this graph shows the nature of a velocity. This graph shows the nature of velocity. And there is another one object is there, that is a B. If we show the motion of that B is in this direction. If we take the slope of this, we got the velocity. This is the velocity of A, this is the velocity of a B. So here we compare the velocity in between the two objects. Here we compare the velocity in between the two objects. So this is known as the position time graph for the relative velocity. So in this graph, see here, A is moving faster as compared to the B. A is moving faster as compared to B. B is moving slow as compared to A. When we see those graphs, we find out that A is moving faster because the rate of change of displacement of the object A is more than the rate of change of displacement of the object A. So A is moving faster as compared to the B. So in this graph we say that VA is greater than VB. If the question is that draw the position time graph, VA is greater than VB. Means the velocity of A is more than the velocity of a B. That time we draw this type of graph. So this is VA greater than VB. Otherwise, VB is less than VA. is less than PA. So this is known as a position time graph. Position time graph is that by taking the position on the x-axis and time on the position on the y-axis and time on the x-axis, the graph is plotted. That graph is known as a position time graph. And with this graph, by using the nature of graph, we say that the velocity of A is more than the velocity of a B. Otherwise, if we compare B with A, that time velocity of a B is less than the velocity of A. So this is a graph. And the E graph ಕೊಟ್ರೆ ನೀವು ಇಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಿರಲಿ ಬರಬೇಕು. That is, a VA is greater than VB. So second one, VA is less than VB. VA is less than VB means the rate of change of displacement of A is less than the rate of change of displacement of a B. So if we draw the graph, so draw the graph for the relative velocity, draw the graph for the position time graph for the relative velocity x and t. There are two objects are there. Means in these two objects we compare the velocity. So x and t. Here we want to show the velocity of a is less than the velocity of a b. So here suppose the object A and the object B. This is the x-axis, this is the y-axis. So A is moving slow than the B. So B is moving fast. B is moving fast. So this is the rate of change of displacement of B is more than the A. So A is moving slow. So if we see this graph, we say that the velocity of A is less than B because B is moving faster as compared to the A. So in this graph, we explain that the relative velocity in between A and B, that is a PA less than PP, or this graph represents that the velocity of a is less than the velocity of a B. This graph represents that the velocity of a is more than the velocity of a B. So this graph represents the velocity of a is less than velocity of a B. So this is the second type of a position time graph, which is related for the relative velocity. Means in this we compare the velocity in between the two objects. Then the third graph, VA is equal to VB. Means there are two objects are there. Velocity of a is equal to velocity of a B. Again take the x-axis and y-axis. On this x-axis we take the time, and on this x-axis we take the position, and rate of change of position is known as a velocity. There are two objects are there, A and B, both are in motion. So due to the change in position, the velocity is possessed. Suppose A is moving with a constant speed, B is again moving with a constant speed. So this is a VA and a VB. So velocity of a is equal to velocity of a B. Otherwise we also draw here VA, take the parallel VB. So here velocity of a is equal to velocity of a B. So this graph shows the velocity of a is equal to velocity of a B. So in this graph, the velocity of both the object is same. Means the rate of change of displacement is the same. So these are the graph. Those are related for the relative velocity, or those are related for the position time graph when objects are in a motion. The next part of the chapter is numericals, and each numerical carries 5 marks. So see the first numericals. along a straight line. Each numerical carries 5 mass. Suppose the first numerical is a car moving along. A car moving. A car moving along. A car moving along a straight line. A car moving along straight line with the speed. With the speed. With the speed. A car moving along a straight line with a speed 35 meter per second. 35 meter per second is brought to rest. Is brought to rest. Is brought to rest within a distance of within a distance of within a distance of 200 meter. 200 meter. What is the retardation? What is the retardation? What is the retardation? And how long? And how long? And how long does it take? Does it take for the car to stop? For the car to stop. So when we solve the numericals, first read the question carefully, then find out the given values and use the related formula and simplify this. For the numericals, in theory exams, calculators are allowed. So here, a car moving along a straight line. A car which is moving along a straight line with the speed of, means the speed is given with the speed of a 35 meter per second. So we know that there are two velocities are there. Those are initial velocity and the second one is the final velocity. Here the initial velocity is given. So first to find out the given value, u is equal to given values right up here, given values. Given values. So in this, the first initial velocity is given, that is u is equal to 35 meter per second. Velocity is given. If brought to rest within a distance, means the distance travel is also given. S is equal to 200 meter. S is equal to 200 meter. What is the retardation? We know that when the final velocity is less than the initial velocity, that acceleration is known as a retardation, means that is a negative acceleration. So in this, the question is that find out the acceleration. Find out the acceleration. And is the retardation and how long it will take? Means what is the time to take the stop car? So T is equal to how much? T is equal to how much? Means in this question there are two parts are there. In the first part we find out the acceleration and in the second part we find out the time. So here which values are given here? Initial velocity is given, distance is given, as well as acceleration is not given. So first, as well as the final velocity is also given. What is the final velocity? A car moving along a straight line with the speed of 35 meter per second is brought to rest. Means the final velocity is equal to 0. So that is a v is equal to 0. Given values, p is also equal to 0. Then use the formula. We know that there are three equations of motion. The v is equal to u plus at, s is equal to ut plus half at square, and the third equation is v square is equal to u square plus 2as. So use that equation to find out the acceleration. So use the first write down the formula. V square is equal to u square plus 2as. Because in this s is given, v is given, u is given, means we easily find out the value of a. Therefore, the final velocity is 0. Final velocity is equal to 0. The initial is given 200 into s. So simplify and find out the value of s. Therefore, 2 distance is given, acceleration is as it is. So 2 into 200 is equal to 400. When this comes to this side, it becomes as a minus. Minus 400 a is equal to 35 square. 35 into 35. Therefore, a is equal to, is this a minus? A is equal to 35 into 35 divided by 400. 35 into 35 divided by 400. So calculate this and we got the answer minus 3.06. This is equal to minus 3.06. So here what is the unit given here? That is a meter per second. Therefore the acceleration is equal to minus 3.06 meter per second square. So this is the acceleration or this is the answer for the first part. So in this we use the formula v square is equal to u square plus 2as. V means final velocity is given in this equation, that is v is equal to 0. Initial velocity is given, u is equal to 35 plus 2 into distance covered is given 200 a as it is. So minus 400 a is equal to 35 into 35. Therefore minus a is equal to 35 into 35 divided by 400 is equal to, therefore this value is equal to 3.06, means A is equal to minus 3.06 meter per second square. Minus means this is known as a retardation. This is known as a negative acceleration or this is known as a retardation. So in this question, the answer for the first part is a minus 3.06 meter per second square. Again there is a second part is there. What is the time required? So this time, here the A is also known, phi is known, u is known, therefore use the related formula phi is equal to u plus at. This is the answer for the first part. Then for the second part, use the formula phi is equal to u plus at. Then final velocity is equal to 0. Initial is equal to 35. Acceleration is equal to minus 3.05 into t. Therefore, 3.05 t is equal to 35. Therefore, t is equal to 35 divided by 3.05. Therefore, the answer is 11.4 seconds. Use the calculator. A is equal to minus 3.06. In the second part, we want to find out the time. What is the time required to stop the vehicle? Therefore, here phi is known, u is known, a is also known. So we use this formula phi is equal to u plus at. Phi is given 0, u is given 35 minus a minus 3.05 into t. Time is always positive. So here plus 3.05 t is equal to 35. Therefore t is equal to 35 divided by 3.05 is equal to 11.4 seconds. See the next question. Numericals are very important in physics. So see the next question. A car moving with uniform velocity. A car moving with the uniform velocity. A car moving with, second numerical, a car moving with uniform velocity. Uniform velocity. A car moving with uniform velocity 54 kilometer per hour. 54 kilometer per hour. He is brought to rest. 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 In traveling a distance. In traveling a distance. Traveling a distance of 5 meter. Traveling a distance of 5 meter. What is the retardation? What is the retardation? What is the retardation? What is the retardation? Produced by the car. So read the question carefully. A car moving with uniform velocity 54 kilometers per hour is brought to rest in traveling a distance of 5 meters. What is the retardation produced by the car? Retardation means negative acceleration. Means in this question we want to find out the negative acceleration. Then find out the given values. First, carefully question ಓದ್ರಿ. ಅದಾಗಿನ given values ತೆಗೀರಿ. ನಿಮ್ಗೆ ಏನು find out ಮಾಡೋದಾಗ ಅದು ತಿಳ್ಕೊರಿ. Then write down the formula. For the formula 1 mass, simplification 3 mass, and writing the answer with the correct unit is a 1 mass. So in this type the mass are divided and each numerical carries 5 mass. So first read a car moving with a uniform velocity. Means the initial velocity is a given. So write down given values. Given values. Given values. Side it given values ತೆಗೀರಿ. Given values. ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ first initial velocity. So write down initial velocity. Initial velocity is denoted by the letter u. Then u is equal to 54 kilometer per hour. Means 1 hour the 54 kilometer. What is the SI unit here? Meter per second. Then convert this value in meter per second. So 54. 1 kilometer is equal to how many meters are there? 1000 meter is equal to 1000. 1 hour. 1 hour convert in second. In 1 hour 60 minutes are there. Then again convert in second. Means 1000 divided by 60 minutes into 60 seconds. 60 minutes into 60 seconds means the value is 3600. 3600. So again simplify this. 540 divided by 36 and the answer is 50 meter per second. So first convert. First check the units. All the units are in SI units. Otherwise all the units are uniform. So initial velocity is given. Initial velocity is given 54 kilometer per hour. So convert this unit in a meter per second. Therefore 1 kilometer is equal to 1000 meter. So 54 into 1000 divided by 1 hour. 1 hour convert in second. That is 60 minutes into 60 seconds. That is 3600. So 54 0 20 cancel. Here 540 divided by 36. Divide this value. We got here 50 meter per second. Second is brought to rest. Is brought to rest means what is the final velocity here? Final velocity is equal to v is equal to 0. After how many distance? What is the distance? And after what is the time it is come to rest? That is a traveling a distance of 5 meter. Means 5 meter distance cover agana. That vehicle is come to rest. Means the distance is given in this question. Distance is equal to 5 meter. Distance is equal to 5 meter. So find out the acceleration. So find out the acceleration. Again use the same formula. V square is equal to u square plus 2as. Again use the formula. V square is equal to, therefore how we solve this? square is equal to U square plus 2AS. This is a related formula. First write down the formula. For the formula, there is a one mass is there. So V square is equal to U square plus 2AS. Substitute the values. Final velocity is equal to 0. Final velocity is equal to 0. What is the initial velocity? Initial velocity is a 15 meter per second plus 2 into distance cover is, yes, distance cover is given. Distance cover is equal to 5 meter. 5 into A. Therefore, 0, 15 square, 225 plus 5 to the 10A. Therefore, minus 10A is equal to 225. Therefore, A is equal to, this is a minus plus minus 225 divided by 10. This 0 point means the answer is 22.5 meter per second square. Therefore, the answer acceleration or that is a retardation which is possessed when the body is moving and come to the rest, the retardation is equal to A is equal to minus 22.5 meter per second square. Write down compulsory unit, related unit. So in this step we find out the acceleration. So first read the given values, convert in the SI units and take the formula, the related formula, use the correct formula, substitute the values and find out the answer. Then take the third equation, third numerical. See the third numerical. A woman starts from her home at 9 a.m. At 9 a.m. walks with a speed, walks with a speed, with a speed, walks with a speed 5 kilometers per hour, 5 kilometers per hour, 5 kilometers per hour on a straight road, on a straight, on a straight road, on a straight road to her office, to her office, to her office, 2.5 kilometers away, 2.5 kilometers away, 2.5 kilometers away, stays at the office, stay at the office, stay at the office up to 5 p.m. up to 5 p.m. and returns home and returns home and returns home by an auto, by an auto, by an auto with a speed of, with a speed of, with a speed of 25 kilometers per hour, 25 kilometers per hour. Select a suitable scale. Select a suitable scale Suitable stay. Plot a xt graph. Xt graph. Plot a xt graph. So see the question. Read the question carefully. A woman starts from her room at 9 a.m. walks with a speed of 5 km per hour. Means one lady ಮನೆಯಿಂದ 9 am ಸ್ಟಾರ್ಟ್ ಆಗಿ ಎಷ್ಟು ಸ್ಪೀಡ್ ಲೇ 5 km per hour ಸ್ಪೀಡ್ ಲೇ ಸ್ಟ್ರೇಟ್ ರೋಡ್ ಲಿಂದ ಆಫೀಸ್ ತನಕ ಹೋಗ್ತಾರೆ up to office. What is the distance of the office? 2.5 km. Means the distance in between home and office is a 2.5 km. Away, stay at the office means one lady at the 9 a.m. with the walking with the speed and the ಎಷ್ಟು speed 5 km per hour speed office go. Office ದಾಗ ಎಷ್ಟು ತನ ಇರ್ತಾರೆ up to 5 p.m. means 60 up to 5 p.m. in office and returns means after 5 p.m. she returns home. But when she returns home, she came with the auto with a speed of a 25 km per hour. Means the speed of auto is more than the speed of that woman. So 25 km per hour. Select a suitable scale and draw a position time graph. So draw the position time graph. So to draw the position time graph, the time is required. Means position time, the time is required. But in this question, the time is not given. Then first find out what is the time required to that woman to go to the home. Go to office. And the office ಗೆ ಹೋಗಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕಾಗದ ಆಫೀಸ್ ಗೆ ಮನಿ ಬರಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕಾಗದ ಅದು ಫಸ್ಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಫಸ್ಟ್ ಫೈಂಡ್ ಔಟ್ ದ ಟೈಮ್ then see here to find out the time we know that the related formula is solution to find out the time the related formula is speed is equal to distance divided by time therefore time is equal to distance divided by speed. What is the distance? Distance is that is a 9 a.m. walks with the speed of 5 km per hour and the distance is 2.5 km. Means the distance in between home and office is a 2.5 km. So this is equal to 2.5 km distance. And divided by speed. Speed is given 5 km per hour. So kilometer cancel. 2.5 is a 2 means this is equal to 1/2 hour. 1/2 hour means what is the second? How many seconds are required to reach the office? 30 hours means 1/2 hours means what is the time required? 30 minutes are required. So this is equal to 30 minutes. The time required for that lady to reach the office with a walk is a 30 minutes. But when she returned home, she came with auto. So what is the time? So for return the home, by walk, by auto. Second part, time is equal to distance divided by speed. So distance is same 2.5 and the speed is 25. 2.5 kilometer and 25 the unit is a kilometer per hour. Therefore, 2.5 divided by 25 is equal to 0.1 hour. So if it is converted in second, that is otherwise if it is converted in minutes, 0.1 into 60 means the time required is a 6 minutes to return the home. So the time required to reach the office is 30 minutes and the time required to reach the home is a 6 minutes. So we use the simple formula. Time is equal to distance divided by speed. Distance is equal to 2.5 kilometer and the speed is given 25 kilometer per hour. So find out this. 2.5 divided by 25 is equal to 0.1 hour. So the answer is 0.1 hour. 0.1 hour is equal to 6 minutes into 60 means that is a 6 minutes. So here the question is that draw the position time graph. So we draw the position time graph or take a scale. This is a time and this is a position. So starting from home 0. Take the time 1 hour, 2 hour, 3 hour. So she start at 9 a.m. From 9 a.m. Suppose this is a 10 a.m., 11, 12, 1, 2, 3, 4, 5 p.m., 6 p.m. Take the suitable scale. At 9 a.m., she start. Time and here the position. 9 a.m. starting 10, 11, 12, 1, 2, 3, 4, 5 and this is a 6 p.m. From 9, distance is, the distance in between home and office is 2.5 kilometers. But the time required to reach the office is 30 minutes. The time required to reach the office is a 30 minutes. Therefore, 9 to 9:30 means here the 10. So the time required to reach the office is a 30 minutes. So this is the position time graph when she reach the office. And up to the 5 p.m. Up to the 5 p.m. she stays at the office. Up to the 5 she stays at the office. Up to the 5, the position is the same. Again, she returned to home after 5 p.m. and the time required is a 6 minutes. Means 5. There is a small time is required to reach the office. So this is the position time graph. This is the position time graph which is related for this question. Means for position, the time required to reach the office is a 30 minutes. That is a 9:30. She reached the office, and from 9:30 to 5 p.m. she stays at the office. That is the position is the same. And after 5 p.m. she returned to home. That is the distance is same 2.5 kilometer. And the time required to reach the home is a 6 minutes. So draw this. So this is a graph which is a related for this question.